and today let's talk about the conclusion of phi of A times B equals phi of A times phi of B when greatest common divisor of A and B is equal to 1. I mean, A and B are co-prime. So we have two methods. And the second method in the video that we talk about the Euler's torsion function, that the second method is the constant product method. And the first method we use bijection to prove it. So if we use constant product to prove this, so let's see what's the conclusion right here. So first, I have talked about it in that video, and let me prove it again. So first, let's see. We have m times n, and it is 1, 2, and so on to m, and then m plus 1, m plus 2, so on to 2m, and then 2m plus 1, 2m plus 2, so on to 3m. So, and so on to n minus 1 times m plus 1, and n minus 1 times m plus 2, and so on to nm. So right here we have this picture. Actually, this is the constant product. Okay, great. Now I'm going to prove each column. In every column, each two numbers are incongruent mod n. So let's choose any column here. So maybe column K. K, this column. So the next number is m plus k. And then 2m plus k. Okay, and so on to what? To n minus 1 times m plus k. Plus k. Okay, great. So now this column, so we chose any two numbers. So these two numbers are what? Let's think. These two numbers are L, m plus k, and L prime times m plus k, and that we said they're congruent, and we use the contribution to prove this problem. So we said they're congruent mod n, and then so their difference is L bracket L minus L prime bracket L minus L prime and times m. So this should be congruent to 0 mod n. So that means n is the divisor of this one. So and n are co-primes. So that means n is the divisor of L minus L prime. And L and L prime only can choose the numbers between 0 and n minus 1. So L and L prime are not allowed to be big enough. That tells us what? That tells us L only could be equal to L prime, right? Because they're not allowed to be big enough. Their difference can't be any multiple of n, like one multiple of n or two multiple of n, except 0 multiple of n. So that means they only can be equal. So now the next thing we're going to prove is that if m and n that is equal to, we chose an example with a 3 times 5 that is satisfied. of course we can use this method, because after we use this method, because in each column we have, in every column, each two numbers are incongruent mod n. So we have proved this. That means in each column there has 5 minus 1 number that are co-prime of 5. So that's right. So that's why we can use this problem, because it's 5 minus 1, so that's 5 to the 5 of 5. So 5 is 3 times 5 of 5. That's right. But the problem is now, of course, let's see why because 3 and the 5, they are co-prime. And so why the condition, the greatest common divisor of A and B are co-prime? We need to let it co-prime. So first, let's see. We can change another path to think about this problem. So we can use intuitive. We can think. So we can have intuition. Intuitive. So what we're gonna do is, let's think. Okay, you see I wrote bijection here, but I don't know place to write. Okay, so let's see here. So first, let's gonna prove. First we use another method to prove 3 and 5. So let's write it down. 1, 2, 3, 3. 1, 3, huh? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, this is it. So now let's see. If we use intuitive, so let's think. 1, 2, 3, 4, 5. 5 numbers are accrued. So how many of them? 3 of them. So intuitive, we think it shall be an average distribution. So we let it average distribute. So we will have in each column we have one number that are not co-prime with 5. So that's 10. You see the place there's 5, 10, and then 15. So that's fine. Okay, great. So now we know we're using intuitive. So 3 times 5, because we have the average distribution. So, but the point is, what about if it's 5 times 5? So that's going to satisfy the condition is greater common divisor. A and B are co-prime. So 5 and 5 are co-prime. But let's try it. So we use the average distribution. So you all know why. Because if it's 5 times 5, so what happened? It is 1, 2, 3, 4, 5. And you see, if it's happen like this, of course you can imagine that's 6, 7, and then 8, 9, 10. So you see, it's not average distribution. It's not average distribution. And then all of the numbers that are co-prime, that are not co-prime with 5, are all on the last column. So that's not average distribution. That's why we can't use it. That's why we can't use 5 times 5. That's why the condition is A and B are co-prime. Right? Okay. So now let's see. Now we shall prove that, what about we use intuition? Of course. You see here, if we had a problem like 3 times 5 to the 2. So what will happen? Let's think here. If we use this method, we can't use it. Because after we prove it, so what does it mean? We can't use this because after we prove it, what does it mean? So each column we have 5 to the 2 minus 1 numbers that are co-prime with 5 to the 2. So that's wrong. Of course not this. So that means we use intuition, the average distribution to prove it, right? Intuitive, or we can say intuition to solve this problem. So average distribution. Okay, so first we need to prove what is the phi of P. What is the value of, this part we are going to prove what is phi of P to the K. This is actually called the value of phi for a prime power. This is actually, we can say this is this is the value of 5 for prime power argument. So we can prove it. So I don't prove it anymore because I have proved it in video that I talk about the Euler's torsion function. So we know that's equal to p minus 1 and times p to the k minus 1. Okay, great. So we know it's equal to this. So we know how to calculate phi of p to the k. So that means we know how to calculate phi of phi to the 2. So that means now we can use intuition then. So let's add 1, 2, 3, and so on. Okay. And so what's the point here? Is that you see each column, how many columns do we have? Sorry, we have columns and 25 rows. Okay, so what's the point now? Let's think. Okay, so we have already proved 3 times 5. So the problem is like 3 times 5. So we know in here, we know it's average distribution. So right here, we only need to, because it's 3 times 5, 32. So it's 3 times 5, and then times another 5. So 5 of this part. So and 5 and 10. So because right here, 5, 10, 15. So each row we have one number that are co-prime with 5. So how many of them? 5 of them. And each of them have like this. So what we're going to do is, you see each column, how many of them? Because we have 5 of these. And each column have 1 of. So 5 of these. So then we have each column have 5 of these. And second column, 5 of these. Third column, 5 of these. So that's why. So of course we know 3. So we know that's 3. So what about 3 times 5 to 2? Of course we have solved this problem. And of course we know what's that? That is phi of 5. So phi of 3 times phi of 5 to 2. Great. Okay. So now we're gonna prove. Now we're gonna prove is that 3 to the 2 times 5. So that's 1, 2, 3, and so on to 9, and so on. We have 5 rows and 9 columns, so we only need to care about phi of 9. So we also can use it here, this part here. Okay. We also can use the value of phi for prime power argument. So right here we have 5, 9, and then times. So each column is same reason, right? Let's see here, because intuition, because you see here, because so first 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and blah blah blah. So we have phi of 5 numbers. 5 numbers are accrued, and 5 of them, and sorry, 9 of them. And each crew we have one number that are co-prime with 5. So right. So 9 of them. So 9 numbers. Okay, 9 numbers that are not co-prime with 5. So and then it should be average distribution. So average distribute. We can say, right. So and each column has one number that are co-prime with 5. So not co-prime with 5. Okay. So that's the point. So that means it's times phi of 9 times phi of 5. That's the point. Okay, so we'll prove that's easy. So now we're gonna prove 3. What about 3 to 2 times phi to 2? So that's very easy, right? And then 1, 2, so on to 9, and then so on and so on. So what are you gonna do? You see. It's the same with solving this method because we have solved this and we solve this. So 1, and we solve this, and we solve this. So right here, 1, 2, 3, 4, 9, and then we have 5 rows, and this is one part, and a lot of parts like this. And how many of them? 5 of them. And each of them each row have, and each part of them have, each row have one number that are co-prime with 5, and 5 of them. So there are 5 of them. So 5 of them, 5 find numbers, right? So what's this? Here, of course, right? 5 of them. So find numbers, right? So okay, great. So now that's 5 of 9 times 5 of 42. Okay, so that's a problem because from this one we can calculate out that 5 of 42 is 20. Yeah, great. Okay, so we have solved the problem. So we have solved the product of the constant product method. So what about the bijection method? The bijection method, actually, at first we have set S and set T, and set S is the input and set T is the output. And we find out a function that is x mod A and x mod B. Okay, good. So now what are we going to do? We have it, right? We have this S and set T and set S, and we let every element in set S plug in this function. So let's plug in this function, and we have every other pair in set T. That's how. So and we create our Chinese manifold from set T to set S. That creates the surjection and injection. Put them together, then that's a bijection. So that's how we solve the problem in the bijection method. Okay, of course, if we use intuition, so not intuition. Okay, and we think how can we use the bijection to have some relationship with constant product? That we can't, because you see x mod A, x mod B, right? That has some problem, but you don't know where is the picture of. Where's the numbers right here meaning for in the constant product? So we can't have the relationship on the bijection method and the constant product. So this is the conclusion of this part of the problem.